When you have a problem like this, y equals 6x squared plus 3x, that's called explicit function, because you have y equals. And you can find the derivative of that. You go, the derivative of that is what? 12x plus 3. Okay. Now, what about if you have a problem that looks like this? Y squared plus 2x plus 7y equals 3. You can't solve this for y, because there's y squared and there's y there. That's where implicit differentiation comes in. Problem like this, I can't solve it for y, so the rules I did before I can't really use. So then what is implicit differentiation? It says you don't have to solve that function for y. You don't have to make it explicit. Just take the derivative. If this was u squared, what is the derivative of u squared? 2u times what? U prime, right? Which is du dx. So the derivative, since y is a function of x, the derivative of that, 2y, but you have to add dy dx, or y sub prime. Just like we did the derivative e to the u is what? E to the u times u sub prime. The derivative of sine of u, we said, is what? Cosine of u times u sub prime. So you can put here y sub prime instead of dy dx if you like the prime. I'll do prime for now because we've been dealing with the prime. The derivative of 2x is what? 2. The derivative of 7u or 7y is what? It's 7, just like 7x. The only difference times what?
Y prime.
Y sub prime. The derivative of any constant is what? 0. Now can we solve for y sub prime? Notice I'm going to collect all the terms with y prime on them on one side.
Factor out y prime.
Yes, factor out y sub prime.
That's your answer.
Not yet. One more step to get the answer. Because you're looking for the derivative. Y sub prime is equal to what? Negative 2 over what?
Oh, that's right.
2y plus 7. Because we're looking for the derivative. What is y sub prime? Or what is dy dx? So the only thing we're going to be doing different here, just like if that was all x's, anytime you have y, when you take the derivative of that, you add dy dx or y sub prime. If you add that to the problem, then it's going to work out perfectly. So that's what today's problem is. We'll make them bigger in a few minutes here.
Pretty sure my teacher when they did that, she took probably 2 classes just in.
Well, a lot of people want to go through the derivation and the math and all the good stuff. Let me take another one. Again, find dy dx. Now, you have two options here. I'll do implicit and I'll do explicit. I'll do it twice. Let's say the implicit, derivative x squared, so this implicit here, The derivative of x squared is what? 2x. The derivative of that, treat y just like x. That'll be what? 8y. Don't forget to add. Anytime you have anything but x, you need to add what? dy dx or y sub prime. Either way, I try to mix and match. Sometimes I use y sub prime, sometimes dy dx. And what's the derivative of 4? 0. Move the 2x there. 8y dy dx is equal to what? Negative 2x.
Divide out the.
Yep. dy dx will be negative 2x over 8y, which is negative x over 4y. We might ask you to find the derivative at, for example, for this one, I might say, can you give me the derivative at the square root? What is find dy dx at the square root of 2, comma, negative 1 over the square root of 2. Can you tell me what the derivative, what the slope of the tangent line at that point? Plug them in. This is your x value. That's your y value. Your x value is what? Is this? Your y value. So it'll be 4 times negative 1 over the square root of 2. That's negative the square root of 2 over 1. This is negative 4 over the square root of 2. You probably remember what I said. When you have a fraction over a fraction, the easiest way? Outside. Outside over what? The inside. Outside, you multiply these two. What do you have? Negative 2. Square root times the square root, they cancel each other out. The inside, you multiply these two, which is what? Negative 4. What's the final answer? 1/2. Now, this is one of those problems. I could have solved it for y. I could have made it explicit. Which says what? 4y squared equals what? 4 minus x squared. Divide both sides by 4. 4 over 4 is 1 minus x squared over 4. And y, to solve for y, what do? Don't you take the square root or raise it to the power of 1/2? The square root. So if you want to find the derivative now, we use the general power rule, which is 1/2 times 1 minus x squared over 4 to what power? Negative 1/2 times the derivative, what's on the inside? The derivative of 1 is 0 minus, that's actually 1/4 x squared. It's 1/4. What's 2 times 1/4? 1/2 x. To make life easy on me, I'm going to plug in the square root of 2 for x right now. See if the answer is the same. That makes the math easier. When x is the square root of 2, when you square that, that's 2 over 4. And this is negative 1/2 times what? The square root of 2. What's 1 minus 1/2? Is that a half? To the negative 1/2. Can we simplify this? Well, let's look at it. That says 1/2 times 1/2 to the negative 1/2, right? Times negative 1/2. And what's the square root of 2?
Isn't it like 1?
2 to the power of what? 1/2. When you have negative exponent, one quick way to fix that, you flip that fraction and change the exponent to positive. Flip the fraction and change the exponent to fraction. When you flip that, that becomes 2 over 1, which is 2, and that's the power of 1/2. You're multiplying 4 things. Doesn't matter which 2 you multiply first. Let's look at this. What's 1/2 times a negative 1/2? Isn't that a negative 1/4? Times 2 to the 1/2 times 2 to the 1/2. When you multiply, don't you add the exponent?
Yeah, so you just get 2.
2 to the power of 1, which is 2. The result is negative 1/2. Is that the same answer? Am I missing a sign somewhere?
No, you got it.
I got a negative here, I got a plus. Let's see if I missed a sign somewhere. Should be the same answer. Minus 2 times the square root of minus square root of 2. Usually if I make a mistake, I got to redo the whole problem. I'm missing a minus sign somewhere.
On the right side, third line from the bottom left to the negative 1/2 exponent.
When you flip it here, you flip this one, and that becomes a plus 1/2.
Gotcha.
Yep. That's a positive 1/2. And x equals 2. I know what the problem is. When x equals 2, I might have wrote this wrong. I just picked a point there. When x equals 2, what is the y value? That should have been actually plus 1/2, not a negative 1/2. Look at the math. When x equals 2, what do you have? Y equals what? 1 minus, when x is square root of 2, what is the square root of 2 when you square it? So that would be 1 minus 2 over 4 to the power of 1/2, right? What's 1 minus 2 over 4? 1 minus a half, that's a 1/2 to this power of 1 over 2, or the square root of that. So that's the square root of 1 over the square root of 2, which is 1 over, that shouldn't be a minus here, it should have been a plus. I wrote that point wrong there. Try to do it quickly in my head there. So when this is plus 1/2, that's a positive here, which will make this number what? and negative, and the two answers matching. I try to do that problem in my head. When x equals 2, I put a minus. It should have been a plus 1/2, not a minus. Everyone see why? Because that's what y is equal to. So when x equals 2, the y value should be a plus 1/2, not a negative 1/2. Can't be. Unless I want the bottom half of it. If I want the bottom half, because that's a, notice that's really what? An ellipse. If you look at that, that's the graph of an ellipse. So the ellipse looks like this. So you can have either the top or the bottom. If you do the top half, that's a positive, because when you have y squared, y equals plus or minus. If I want the bottom one, I'll make that a minus. So I could have left that as a minus, then I have to put a minus right here. Anytime you have y squared equals a value, then y equals either plus or minus. There's two functions. I use the plus, the top 1/2, which means that point cannot be negative. If I wanted to use the negative here, I have to put a minus here, not a plus. That would be the bottom half of that picture. Remember, to be a function, you need to have the inverse. To be a function, you want to have a one-to-one function. So you're either going to have the top or the bottom, because you can't have both. It's not a function. The vertical line test. So I could have left it as a minus here. Then I will have to put a minus here. By putting a plus, I'm using the plus, the top half of that picture, and the two answers match. It is much easier not to go through this headache here and trying to find the function and take the derivative. That was way easier. So implicit differentiation, I'm a big fan of it. And you're probably going to be a big fan of it when you start doing the work there. I'll try some more. Let's say we have this problem. 8x squared plus y squared to the power of 2 equals 100xy. And I want to find dy dx, the derivative of that. Let's do the left side first, then we'll go to the right side. The left side will be what? 8 times 2, which is what? 16. Keep everything the same and subtract 1 from the power. That's the general power rule. Are we done with it? No. You got to multiply by the derivative what's on the inside. What is the derivative of x squared?
2x plus 2y dy dx.
Bless you. 2y dy dx. Yes. We'll come back and clean it after. Or if you want to clean it now, you can take the 2x multiplied by the whole thing. Then take... Yes.
Why do you have to say dy dx?
Anytime you take in the derivative, you have to include dy dx, because y is a function of x. It's not just x. That's like you know? Could be x squared plus 7 or 6x cubed plus 3. So you have to multiply by the derivative of that.
It's the same thing as you used on y prime.
Correct. Y prime or dy dx. So now 2x times this, that'll be what? 32x times x squared plus y squared. Leave it like that. Who cares? Plus 32y times x squared plus y squared times dy dx. That's just the left side. Now the right side, how do we take the derivative there? There's the 100. What's the derivative of xy?
1.
No.
It would be
Y prime? X, Y, with apostrophe or prime thing? Just
No.
dy dx?
No. We have xy, right? What does that mean, xy?
X times Y.
X times y. You have to use the product
Oh,
rule.
X, Y.
The product rule. The first, which is x, times the derivative of y, which is what?
One.
dy dx, plus the second, which is y, times the derivative of x, which is 1. Now you might say, well, how come you don't put dx dx? Well, if you put dx dx, what is that equal to?
One.
1. That's why we don't put it there. Now let's clean the right side. 100x dy dx plus what? 100y. Now all the ones with dy dx, you want them on one side, everything else on the opposite side, meaning this one has to come to this side and that one has to go to that side. And when you change side, you always change sign. So when I bring that to this side, it becomes a negative. 32y times x squared plus y squared dy dx minus 100x dy dx equals 100y minus 32x squared plus y squared. I can factor dy dx. Those problems get me tired. And what's the last step? We need to solve for dy dx, so we need to divide. So what is dy dx equal to? It's 100y minus 32 x times x squared plus y squared, all of that divided by 32y x squared plus y squared minus 100x.
Quick problem.
Fun, fun, fun. If that was actually a problem on the homework, they probably, I'm sure they'll pull a 4 out from each one and simplify it, because they're all divisible by 4.
So we get 25.
So if you pull the 4 out,
You get 4 times so 25.
25y minus 8x x squared plus y squared
All over 8 y.
all over 8 times
8 times y.
this will be what, 4y minus 25x. Oh,
No.
factor 4 out
Yeah, you
and 8 left on the inside.
yeah.
And what's going to happen to the 4s?
They cross out.
They cancel. So you factor a 4 out of each one. That they probably expect you to do. Or if you're lucky, they'll go find the derivative at this point. When they give you a point, you plug it in, it makes the algebra much easier. Unless you have fractions and square roots and all that. But if they just give you numbers, like 1 and 3, plug them in. Go, when x is 1, that's 1, 3, that's 9, that's a 10 here. Boom, that's just a number. So start plugging the numbers earlier, it makes the algebra much easier. I'll try to color more of these problems. But that's what implicit differentiation. Let's say we have sine of y equals x. Again, even if your intent was to change that to solve it for y, you can by taking the inverse sine. But good luck taking the derivative of this. Does anyone know what the derivative of the inverse of sine? No. That's coming up in the next section. The arc sine, the arc cosine, arc tangent, arc secant, cosecant, cotangent. So I'm not going to solve, I'm not going to switch it to this and take the inverse. I don't know what the answer to this. So I'll just use the implicit differentiation. What's the derivative sine of y? Again, just like sine of u. Cosine y times y sub prime or u sub prime. What's the derivative of x? 1. Can you solve for y sub prime now? 1 over cosine y.
Which is weird. It's almost like that's the inverse of sine.
Well, if you think about that, it says sine of y equals x. If you make a triangle out of it, the angle is y, right? And the sine is what side? This is x over 1. The sine is the opposite over what? Hypotenuse. This is the opposite. This side must be x, and this must be 1. Can you find the length of this side? Sure, Pythagorean Theorem, right? I called b here. 1 squared equals what? B squared plus x squared. 1 minus x squared equals what? B squared. B equals what? The square root of 1 minus x squared. So what is the inverse of that? Let's see, what's the cosine of that? It's 1 over. What is cosine y? Once you know what the side is, cosine is the adjacent over the hypotenuse. What's your adjacent?
Square root of 1 minus x squared.
What's interesting, if I show you now the next section, where is it? What's the derivative of the inverse sine of, well, we're using x here. If this is x, will be 1 over the square root of 1 minus x squared. That's the answer we got here. Well, we're going to memorize these today, or next class. They keep on coming. Yep. But that's really what's happening, is exactly what I did here. Now, if this is not just x here, if that was x squared plus 7, then we'll doctor it by multiplying by the derivative of that.
Do you think this world would be like that trig?
Well, without trig, I can tell you we're probably all in trouble. Yep. Everything around this, based buildings, everything based on trig. You know?
You can't get a bridge without trig.
Nope.
No. Bridges are hugely trig.
No, you can't do much with the trick. You think you can too, until like you learn it. I feel like
Well, go over that bridge and fall right into it.
you know.
Let me try one more. Does anyone know this is what? The graph of what? Anyone? That's a circle with a radius of 5, right? Center of the origin.
Square root both sides.
I'm going to find the second derivative.
Is it written like that? D squared y
Yep.
dx
Yep.
squared? Well, it's not squared, it's just...
Second derivative y with respect to x. Notice the 2 on top of the d, the 2 on top of the x here. That's how it's written. If I do implicit differentiation, because that'll be easier, the second derivative means you got to find the first derivative first, then take the derivative of that. So I got to find dy dx first. Derivative x squared is what? 2x. The derivative y squared is what? 2y times dy dx.
0.
And the derivative 25 is 0. Equals negative 2x, or dy dx. If you divide them, that's a negative x over y.
And you want the derivative of that?
Now we're going to do the derivative of this, yes.
So y is a negative 1.
So what's the second derivative? I got to take the derivative of this one. Again, I got a fraction, I got to use the quotient rule. The bottom, which is y, times the derivative of the top, negative 1, minus the top, which is negative x, times the derivative y, which is what? 1 dy dx. You don't have to put the 1. All of that divided by what? The bottom squared. So the quotient rule. G times f prime minus f times g sub prime. All of that divided by g squared. Clean that. Negative y plus x dy dx wait a minute. We know what dy dx, right? We just did that. Dy dx is this one. It's right here. So replace dy dx with negative x over y. You'll have negative y plus x times negative x over y negative y over 1 minus x squared over y divided by y squared over 1. I'm going to multiply everything by the LCD, which happens to be y. So what do we have? Negative y squared minus x squared over what? Y cubed, if I can fit the answer here. Could I simplify that actually? Even more? Look at that answer. You can take a minus sign out of the top, right? If you take a minus, you'll have x squared plus y squared, or y squared plus x squared. I just took a minus sign out of both these. And the reason I pulled it out, because I took a peek here, and what's x squared plus y squared equal to? 25. So I can make that negative 25 over y to the third. Now I'm not sure where they want to stop. Couldn't tell you. Could be any spot.
Get to 25 from here?
This one?
Equal 25
Right here.
Okay. All right.
X squared plus y squared equals 25. I start to walk away from the problem. I notice, oh, wait a minute, if I pull a minus sign, I get this piece which is equal to that. So why not put 25 then? Again, if I'm lucky, they give me a point. If they give me a point, x and y, who cares? I just plug them in. I don't have to do all this algebra. But if they don't, then I got to do the extra algebra here. That's implicit differentiation.